If you were to perform an experiment where you tried to identify some of the cooking extracts you might have at home by dipping them into on a Q-tip and putting them on your tongue but holding your nose while you tried to, quote, taste it, there are some, such as vanilla, that you think you recognize its taste, but then you would realize that you only recognize its smell. Actually, most of what we think we are tasting is actually our sense of smell. And then additional senses, such as the temperature of the food, the texture, and then even, with the case of like spicy foods, the sensation of pain. All of these can contribute to our sense of taste. Our smell can not only contribute as the odorants become volatile and pass through the nostrils, but also they can go through the back of the nasal cavity in a pathway, what is known as being retronasal, and we can smell odorants in our food that way as well. Why is taste so simple compared to smell? Well, taste focuses on an important problem. If an individual is chewing something in their mouth and thinking of ingesting it, there is a narrow window of time where you can decide whether or not this is a good idea. If you make a mistake, if you ingest something that you shouldn't, there are involuntary ways of eliminating it. One could vomit or have diarrhea, but the sense of taste gives the last voluntary window on making the decision on whether something should be ingested or not. One of the basic tastes is the sensation of things which are sweet, which are typically carbohydrates. These are sources of energy, which are important because we use a great deal of energy, not only for things like muscle contraction, but also the pumping of ions in a nervous system, and also then just keeping warm. Even on cold days, our body temperature is almost 100 degrees. There is an enormous number of calories needed to get the human body through a day, and so we recognize sweet taste as good, and we want more because this will provide us the energy we need to get through the day. We also recognize salty tastes as good and want more. The reason this is adaptive is because the nervous and muscular systems run on electricity, and electricity depends on the concentration of electrolytes, ions in solution. And so if we sweat away too many ions, then our nervous and muscular systems would have trouble functioning, and so therefore the salty tastes help us seek out the ions that these systems need. The sour taste is important because we depend on a number of things we get from plants, such as vitamin C, which can be gotten from citrus fruits, and so something which is mildly sour might actually be critical to incorporate in our diets. But strongly sour tastes are indicative of things which have been decomposing, that bacteria have been breaking down and producing acids. And many of these spoiled foods could accumulate bacterial toxins, or say the eggs of parasitic worms as flies land on it. And so we tend to dislike strongly sour taste, which is a way of protecting ourselves from food which may have spoiled and may be capable of causing an infection and getting us sick. We also dislike bitter tastes, which are perceived on the back of the tongue. While we have one sense for bitter, there is a great diversity of molecules which trigger this bitter taste, and they include poisons. Now, plants don't like animals as much as we think they do. After all, animals eat plants, and plants can't brush, say, insects away or run away from the animal herbivores. One of the ways they defend themselves is by putting toxins in their leaves, so that if any animal eats a large amount of the plant, it will be poisoned as a result. Our bitter taste detects many of these toxic compounds, and things which are strongly bitter, then we want to spit out. Unfortunately for the modern diet, many vegetables, for example, do have a slightly bitter taste, and so children might be, say, less inclined to eat it despite the nutritional value. We can tolerate some low level of toxic molecules from plants. After all, our liver helps to break many of these down. But the bitter taste is there to protect us from plant toxins. The fifth taste of umami, the Japanese word for savory, recognizes amino acids and short peptides, which is important because there are essential amino acids that our bodies cannot synthesize and therefore must be incorporated into the diet. And so therefore, if we like the taste of foods which have amino acids in it, we are more likely then to get these essential amino acids which our bodies need. There is some research which indicates that a sixth primary taste exists in order to detect fatty acids, which would be an important energy source, in addition to some fatty acids actually being essential in low quantities. And so therefore our sense of taste is not as nuanced as our sense of smell. We're not identifying the type of cheese something is, or the type of wine, or the balance of the spices, but we're answering basic questions. Should this food be ingested? Will it give us energy? Is it sweet? Will it provide ions for our nervous and muscular systems? Is it salty? Does it have amino acids in it? That's the umami or beefy taste. Might it have fatty acids in it? All of these are good tastes, and we want more. Is it strongly sour, in which case it might have spoiled and we might get sick by eating it? Is it poisonous? That's a bitter taste. So the tongue is trying to answer these basic questions before we swallow the food which we have put in our mouths.